Norton's theorem. This Norton's theorem states that any linear circuit with current and voltage sources can be replaced by an equivalent circuit containing a single independent current source and a parallel resistance. Now look at this. This is Norton's equivalent circuit where I Norton is the Norton current and R Norton is the Norton resistance. The main difference between Thevenin's theorem and Norton's theorem is that Thevenin's theorem provides an equivalent voltage source and an equivalent series resistance, while Norton's theorem provides an equivalent current source and an equivalent parallel resistance. Now look at this example problem. If you have a circuit like this is a voltage source of 12 volts which is connected to a 2 ohms resistor. It is further connected to a resistor of 6 ohms. Here is another resistor of 3 ohms and here is load resistor which is of 1.5 ohms. Now if you want to calculate IN which is Norton current and RN which is Norton resistance, you have to follow some steps. In first step, you will short this load resistor. So this circuit will look something like this. Okay, as you can see, you have shorted this load resistor. Now this is terminal A and this is terminal B. This is 2 ohms. This is 6 ohms. This is 3 ohms. Now as you can see, this 6 ohms resistor and this 3 ohms resistor, they are in parallel, and this parallel combination of 6 ohms and 3 ohms is in series with this 2 ohms resistor. So in second step, before finding this Norton current IN, you will first calculate the total resistance, which is 2 ohms plus 6 ohms, which is in parallel with 3 ohms. Okay, it can be rewritten as 2 ohms plus 6 multiplied by 3 divided by 6 plus 3. Okay, after solving this, you will get 4 ohms. So the RT is 4 ohms. From Ohm's law, we know that V is equals to IR. So VT is equals to IT RT. Now for IT, this equation will become VT divided by RT. We know that RT is 4 ohms and VT is 12 volts. Therefore, IT is 3 amperes. Now, we will find IN by applying current divider rule. From current divider rule, we know that Ix is equals to IT multiplied by Rx divided by R equivalent. Here, as we know that the Norton current is flowing here in this loop, therefore this Rx will be 6 ohms. This IT is 3 ampere that you have just calculated, and this R equivalent will be 3 ohms plus 6 ohms, because in this loop these two resistors, they are in series. Therefore your IN will be 2 amperes. Means after solving this, you will get 2 amperes. Now, what will you do in next step? In next step, you will open all current sources and short voltage sources and open load resistor. As you can see, there is one voltage source in this main circuit and there is your load resistor which you have shorted. It means you have to open this load resistor. Okay, so now I'm shorting this voltage source here, so the circuit will look like this. Okay, the voltage source is shorted and here I have opened this load resistor. So this is terminal A and this is terminal B. Okay, now this is 2 ohms, this is 6 ohms and this is 3 ohms. In next step, you will calculate Norton resistance, which is Rn. How you are going to calculate this? Now look at this circuit which you have made in step 3. As you can see, this 6 ohms resistor and this 2 ohms resistor, they are now in parallel with each other, and this parallel combination is in series with this 3 ohms resistance. So your Rn will be calculated by this formula or equation, 3 ohms plus 6 ohms, which is in parallel with 2 ohms. It can be rewritten as 3 ohms plus 6 multiplied by 2 divided by 6 plus 2. After solving this, you will get Rn is equals to 4.5 ohms. Okay. Now, what will you do in next step? In next step, you will draw your Norton equivalent circuit. How? You will connect this Rn in parallel with current source and then reconnect the load resistance. So your Norton equivalent circuit will be something like this. This is your current source which is of 2 amperes. Now you will connect in parallel Norton resistor which is having the value of 4.5 ohms, and here you will reconnect your load resistor which is RL. Now if you are asked to find load current through this load resistor, how you are going to find this? You are going to find this load current using CDR. So the formula will be IN multiplied by Rn divided by Rn plus RL. Okay, and then if you are asked to find voltage across this load resistor, then you will use this Ohm's law. VL is equals to IL multiplied by RL. You know the value of RL. You just calculated the value of IL from this equation. So this is how you will find your voltage across this load resistor. So this is your Norton's theorem.